Good afternoon. So this is Bhavani, Department of Physics and Electronics. Today we are going to discuss about frequency modulation. So now let's see. So before going to explain frequency modulation, what is meant by amplitude modulation definition? Amplitude modulation is a technique of modulation in which the instantaneous amplitude of carrier signal varies in accordance with the amplitude of modulating signal. So while frequency and phase of carrier remains a constant in amplitude modulation. Next, angle modulation is subcategory of frequency modulation and phase modulation. So today we are discussing about frequency modulation. So the definition of frequency modulation is a technique of modulation in which the frequency of carrier is varied in accordance with the amplitude of modulation signal. So here we can see the difference between the modulating signal and the carrier signal. So in carrier signal we have in three categories. The one is no frequency change, and the second one is maximum frequency, and third one is minimum frequency. So in modulating signal, the signal will be same from one point to the another starting point to the ending point. In carrier signal, so the frequency will be changing. So before frequency and after frequency we can see the graph. So it's a formula for modulation index, that is frequency division. So by modulating frequency, so defines the ratio of frequency to the modulated frequency. Now division ratios, these are the formulas for the frequency. Percentage of modulating indication of FM. FM means frequency modulation. The percentage modulation is defined as the ratio of the actual frequency deviations produced by the modulating signal to the maximum available frequency deviations. Percentage of modulation index is actual deviations by maximum allowable deviations. Now let's see the mathematical representations of FM. FM is frequency modulation. This is the equation for the frequency modulations while comparing in mathematical representations. So this is the formula for carrier signals. In carrier signal we have different changes in frequency. The one is maximum frequency, another one is minimum frequency, and third one is no frequency. So frequency spectrum of FM. So what is meant by actual frequency spectrum is so graph of amplitude various frequency. The frequency spectrum of FM waves tells us about number of sideband represents in the FM wave and their amplitudes. So FM frequency spectrum means it decides the number of sidebands, number of waveforms it will be generated. So bandwidth of FM is can we say bandwidth of FM is infinity. So bandwidth, we can't calculate the bandwidth for the frequency modulation. It depends on the frequency of nature. So next one is types of frequency modulations. So types of frequency modulations are narrow band frequency modulation and wide band frequency modulation. These are the two types of frequency modulations. So this is the table for a comparison between narrow bandwidth and the wide band of frequency modulation. So frequency modulation index is less or slightly greater than 1, and in WBFM is greater than 1. So these are the different categories. One is modulation index, and the second one is maximum deviations and range of modulating frequency, modulation index, bandwidth and applications. These are the different categories while discussing about narrow bandwidth and wide bandwidth. So representation of frequency modulation. So here we see the graph of frequency modulations. So generations, we have types of frequency modulations and different types of generations. Generations is one is direct method and second one is indirect method. Indirect method we have two categories. One is reactance modulator and second one is vector diode. So indirect method we have one module, that is Armstrong method. So now let's see the reactance method. So reactance modulator is a illustrates in figure. It is basically stands common emitter class amplifier resistors 1 and 2 from voltage divided to bias the transistor into the linear region. So here reactance method is construction using the amplifiers and amplifiers resistors and transistors. So these are the components while constructing the reactance method. Next one is varactor diode modulator. So here we have the name varactor diode modulator. So in this we use the DC bias and oscilloscopes and diodes, some resistors of constructing the varactor diode modulators. So limitations of direct method of frequency generations. One is very difficult to get high order stability in carrier frequency, because in this method the basic oscillator is not a stable oscillator. It has controlled by the modulating signal. And second one is generally in this method we get destroyed FM due to non-linearity of the varactor diode. These are the two limitations of direct method of frequency modulation generation. Next, Armstrong method. It is comes under indirect method. We have seen direct method. One is reactance and second one is varactor. In indirect method we have one module, that is Armstrong method. So in Armstrong method generates the double sideband surprised carrier signal, phase shift this signal and then returns to carrier to produce a frequency modulated and signals. A frequency modulation generates high quality audio and greatly reduces the amount of noise on a channel when compared with the amplitude modulations. So in Armstrong it means indirect signal we have two double sidebands, and when compared to the direct method we have a single sideband it will be generated, but indirect method it generates double sidebands. And with carrier signal we have three stages of frequency. One is no frequency, second one is maximum frequency, and third one is minimum frequency levels. So applications or advantages disadvantages of frequency modulations. Here we can see the advantages of frequency modulation. One is the transmitted power remains constant. Second one is FM receivers are immune to noise, good capture effect and no mixing of signals. These are the different kinds of advantages of frequency modulation. Here some of disadvantages also. That is it uses too much spectrum space and bandwidth is wider, and index can be in the low minimized to the bandwidth users. So these are the some types of disadvantages. And applications, coming to the applications, frequency modulations uses everywhere because we are running in a real-time world. So frequency modulation we have to generate in different kinds of applications. For example, FM radio broadcasting, sound transmission in TV, police wireless. Not only these applications we generate everywhere in the real world. So communication purpose, everywhere we have the frequency modulation. Here the concept of frequency modulation. So here we saw the definition of frequency modulations and kinds of frequency modulations and different generations of frequency modulations, and applications, advantages and disadvantages. These are the different concepts included in FM's frequency modulations. Thank you for